Hello guys, welcome to a new video. We are going to keep working on this lab that I've been working for about a week now, maybe less than a week. But in this video we are going to fix some configurations that I did wrong. We are probably going to do some changes to the tunnel once again. But we are going to leave that IPSEC for last. So on the last video we configured VRF green, VRF yellow. We also did NAT, we did PAT. So we did port address translation. But then at the end the video was getting too long, so I did not configure the routes. So the VRF green network cannot go out to the network, so it cannot communicate with any of the other routers or the other networks. And also the VRF yellow cannot communicate outside. So in my configuration I did a couple things that I shouldn't have done, or I configured it wrong. So the first one I'm going to show you. We are going to go to router 12, and in router 12 enable let's just do a show run. So the first one that I want to configure correctly is the NAT. I'm supposed to say NAT, and I'm supposed to add the VRF, because if you don't do the VRF, we won't be able, it won't work. Let's see where it is. So this one right here, the IP NAT inside source list 1 interface gigabit/2 overload. So this one is wrong because I need to specify the VRF. So the first thing that I need to do, actually, let me go ahead and get out of here. Config T. So I need to remove this one right here. Okay. So, but before we do that, I'm going to show you why it's not working. Right. Before we do that, let's go ahead and go to green. Okay. And what we're going to do first, let's go ahead and configure the route. So what we need to happen with the routes is I want VRF green to use the default gateway. I wanted to use a default gateway whenever it is going to, let's say, if it is going to the 20 network or to the 172 network, I want you to send it to 20.1.1.1, right? And when it's going to the 192.168.3 network, and when it's going to the 192.168.4 network, I'm going to configure static routes to go to the 20.1.1.1. So we need to go ahead and configure that. The way that you do that, let's see if I remember, it is IP route. So we are going to configure the route for VRF green to go out to 20.1.1. So IP routes, we are going to say VRF. We are going to specify VRF green. Then we specify the destination. So 192.168. That's 0.0. 255.255.0.0. So if I do that, it is going to be able to take the 3 network, the 4 network, and the 3 network. So both of them are going to be in there. So then you want to do the default, where you want to send. I want to change 20.1.1.1. But then at the end you need to specify that this is going to a global, right? Because we are doing it from a VRF, and then we are saying send it to 20.1.1.1, which is in the global global route. So if you do show IP route, we are going to see that the 20 network is in the global network. Okay, sounds good. Sounds good. We also need to do it for the yellow network. Yellow. There we go. I did it wrong. It needs to be VRF and then yellow. There we go. Also, if you are going to that 172 network, the 16.0.0, we need to send it to 20.1.1.1. I did this again. VRF. There you go. And then we need to say yellow as well over here. There we go. So I configure those static routes. And those static routes means that if VR green wants to go to this network, I want you to send it to 20.1.1.1, which is located in the global IP route. Also did it for the yellow network. And I also did it for the 192 network, where I send it to the 20.1.1.1. But now if we see the do show IP or do show run, I'm just going to include NAT. You can see that we are only NATing for gigabit 0/2. We want to NAT for 0/1. So if we go and say let me get rid of this. What I want to say is, and this is going to be run, but I want to show you guys that it's actually run inside source list 1 interface gigabit 0/1 overload. There we go. So now let's try to ping from this screen. I want to ping the 20.1.1 network. And what's going to happen is that, oh, it's saying destination host unreachable. Interesting. So it is unable from VRF green. We are unable to reach the 20.1.1. Okay. What if we also do from here? If we want to reach the 20 network, uh, 20.1.1. So let's send it to, let's see, if IP route VRF green 20.1.1.0 inconsistent, so 20.1.1.0 to 255. There we go. So let's send it over here. Yep, that makes more sense. Let's see if we are able to. Yep, so as you can see, we are not getting the host unreachable now because we know how to get there. Also, let's configure that for the yellow as well. Okay, so as you can see right now, we are not getting destination host unreachable because we now have that route to get there, right? We are sending it to 20.1.1.1. But what's happening is that NAT is not working, and I'm going to show you how you're able to see that. If you do enable, if you do a debug IP ICMP messages on, you're going to see that the destination that we're getting is 172.16.5.2 network. So what is happening right now is that NAT is not working. Why it's not working? Because we're supposed to be getting 20.1.1.2 destination, right? And route 13 does not know how to get to this network. So therefore we need to configure NAT correctly on router 12. So let's go ahead and just go ahead and cancel that on the green computer. Let's go into the router 12, and what we need to do first let's go ahead and say, let's go ahead and negate this one. Say no. Also negate it for 2 gigabit 2. It said it didn't find it. Do show run include NAT. Okay, that's fine. Tunnel destination, that's fine. NAT IP inside, that's fine. Let's also go ahead and do show run. Let me do a do show run and see if those interfaces have configured the inside and outside correctly. So we are going to see the gigabit 0/0.5 and it says inside, that's good. 0/1 says outside. 0/2 is outside. And then we see 0/3.6 inside. Okay, so that's good. So now what we need to do is we need to go ahead and configure the NAT translation with VRF correctly. So we are going to do a IP NAT inside source list 1, and then interface, and then I believe is interface gigabit 0/1, and then we are specifying VRF green, and then we are saying overload. We need to do that for VRF yellow as well. Do show run include NAT. Now we can see it over here. Let's go ahead and see if we do a for gigabit 0/2, which is going out this way. And then let's do show run include NAT. Okay, so what is happening right now is that we can only do it for we can only do NAT either for gigabit 0/1 or 0/2. We cannot do it for both. So I believe we need to create another access list probably. So let's go ahead and change this to 1, and then we can configure that later. All right. Do show include NAT. So there we go, that is good. So now what I want to do, I want to verify that NAT is working. Now it should be working. If we go to router 13, instead of 172.16.5.2, it should give me that IP address of gigabit 0/1, which is 20.1.1.2. And now you can see that we are getting replies because router 13 knows how to get to 20.1.1.2. And there we go, 20.1.1.2 instead of 172.16.5.2. So NAT, we just fixed NAT. So that's how you would do NAT. So now if we want to go to gigabit 0/2, I think we need to probably do another access list. Let's do a show run just include access list. See if I get any hints. Okay, so what we're going to do, we're going to configure just access list 2, basically the same. So access list 2 permit 172.16.0.0 255.255. There we go. So now let's go ahead and create and see if that works. So access list number 2, do show run. I want to include, this is my favorite command, NAT. So there we go. So now you can see that since we are using another access list now, we are able to configure it we're able to configure another one, but this one needs to be, I did this incorrectly because I need to put gigabit 0/2 instead of 0/1. Let's say no, and then let's say /2, and then let's do the show run include NAT, and we just see 3. There we go. So now that is great, so that it is working correctly. And now let's go ahead and do it for the VRF green. Okay, and if we do a show run include NAT, there we go, we are now natting, so that is great. So that is done. We have configured NAT, all of that is good. Let's see what else we can do. What we can do now is that I want to remove that that GRE tunnel. I don't want to use the GRE tunnel, so what I'm going to do is just a simple, site to site connection instead of like the GRE, because if we ping from any of these devices, it doesn't go through the tunnel. And for me, that I remember, for this to go through the tunnel, I'm gonna need to configure just static routes, sending all the send all the routes and point it to the IP of the tunnel. But I don't want to do that. I want to keep using OSPF that I'm using over here. So therefore, I'm going to need to configure a site-to-site VPN tunnel. So I have almost everything configured. What I don't have configured is the crypto map. So what we need to do is that let's go ahead and go to route 12 first. So let's go ahead and interface tunnel. Let's go ahead and remove tunnel 12 real quick. Not do, I want to say no. Bye bye. So we have removed that. If we do show run, so we can see the policy configuration. We're also going to see the IPSEC key configuration, and then we also need to configure that access list. So that access list, it is going to allow that traffic to go in, right? So I'm going to specify what interfaces I actually want to go into this network, right? So let's go ahead and do that. Let me see. We are going to use the same crypto policy 12. We are going to keep that. The tunnel is going to be the same. The profile, we do not need a profile, so we can go ahead and remove that profile. We select that and say no. Say no. Okay, that has been removed. So now let's go ahead and configure that IP access list. So we are going to do a IP access list. We are going to just do an extended one. Let's just call it VPN. Let's just call it VPN. And in here, what we need to do is we need to permit, what are we going to permit, right? We want to permit IP, and going from the source address of 172.16.0.0, which is going to take either 172.16.5.1 or 172.16.5.0 or 172.16.6.0 network. So both networks, 255.255. There we go. Now, where's the destination? So if it is going to, let's say, if it's going to the 20 network, 20.1.1.0, I want you to encrypt it. Also, if it is going to the network, the 172 network right here, I want you to encrypt it. Command incomplete. Let's see. Oh, that 255 again. I want you to encrypt it. Also, if it's going to, it is the 192.168.0.0 network, I want you to encrypt it. 192.168.0.0 network, I want you to encrypt it. Okay, exit. So now what? Let's see. What I want to do, let's see. If we want to do, we need to go ahead and create a crypto map. And in that crypto map, we are going to set the peer, we are going to set the transform set, and we are going to set that access list. So crypto map, let's just call it map 12. It's going to be an IPSEC. Is it? So let me see. I'm doing this. Let's see. Crypto map 12. We can say 10. Then we can say IPSEC with IPSEC. Okay. So over here we need to set the peer to 20.1.1.1. We need to set the transform set. I believe it was called T set 12. Let's see, there we go. T set 12. T set 12. Then we're going to set the, we are going to match the address to just VPN. That's what I call it. There we go. So that is great. Let's go ahead and save this configuration. Let's go ahead and go to router 13 and basically almost do the same, right? Let's go ahead and go enable config T. What I want to do, let's do a do show run, and we need to remove that IPSEC profile, and let's see, I think that's all we need to do, just like we did on the other side. Remove that IPSEC profile and add that access list, right? Which is the, remove the tunnel and the IPSEC profile. This one right here. Let's say no. Okay, so no tunnel, no interface tunnel 13, and then we should be able to remove the crypto IPSEC profile. Then we are going to say the IP access list extended. We are going to be calling this VPN. And what we need to allow is we want to allow the 172 networks and the 192 network to be able that whenever we reach any IP address in router 12, I wanted to encrypt it. Okay, so if we do a, let's see, we do a permit IP coming from 172.16.0.0 to 0.0.255.255, going to, if it is going to, let's say 20.1.1.0 0.0.0.255, I'm going to encrypt it. And also if it's going to the 172 network over here, I think we're gonna need to be more specific so we don't get this access list all messed up. So 172.16, that's 5.0. And also that's 6.0. Alright, so then we want to do the 172.168 network, or the 192.168, going to the 6 network and going to the 5 network. And we also need to do the 20 network, 20, that one, that's 0 network. Okay, a lot of access lists, but that should make sense. Hopefully I don't get it messed up, but I shouldn't. So that is good. Now let's go ahead and create the crypto map. Exit crypto map 13. Let's say 10 is good. IPSEC ISACamp. And in here we need to set the transform set, which is called tset13, I believe. Verify that over here. There you go, tset13. And then we need to set also, what is the other thing that we need to set? We need to set the peer. Peer 20.1.1.2. After we do that, we need to do the match. We are going to match that address, and we call that access list VPN. Exit. Now we need to go into interface gigabit0/1, and then we need to attach that crypto map. So we do a crypto map. What did I name it? It was a map dash 13. What did I name it? Map dash 13. Now we need to go into router 12, and we need to go into interface gigabit0/1, and we need to add that that crypto map dash 12. Crypto map 12. And here we go. ISACamp is now on. That is a good sign. And show IP or show crypto IPSEC SA. We have format IPSEC SA, so that is looking good. All right, let's go ahead and go to R6. Let's see what happens when R6 tries to communicate with 20.1.1.2. Hopefully it works. 20.1.1.2. Unless let me go. Whoop. That is great. So for us to see if it is getting encrypted, we need to show that IPSEC SA again, and it's not being encrypted. So what did I miss? So if I send it to 20.1.1.2, it's not being encrypted. What if I send it? Okay, 172. So we are doing NAT. So here it comes NAT again. I believe this is because of NAT. Since NAT is translating this, what if we say so whenever we do NAT, so in the access list for NAT, do we have to? I think it's not going to work with NAT. Once again, I'm gonna need to figure a better way to do this because it's not being encrypted. I mean, everything is good. What if we ping from this guy right here? 20.1.1.2. Still nothing. It is, yeah, we're using port 500. Oh, did I not do for this guy right here? Let me go ahead and remove this first. Always forget to do the transparent mode, but I don't think it is going to work anyways. but let's go ahead and do this. Crypto IPSEC. Transform set. Why is it giving me an error? Crypto IPSEC transform set T set. Interesting. 12 ESB. Oh, because I'm not in the config mode. Duh. Wow. I need to sleep. Config T. Mode. Transparent mode. Or transport mode. Am I able to copy from here? No. So first, let's go ahead and remove this. And then we are going to go in here, do mode, transport mode. Interface gigabit 0/1, shutdown. Interface gigabit 0/1, so we can force shutdown, no shutdown, no shutdown. Or actually, there we go. BGP to show IP to show crypto IPSEC SA. Okay. To show crypto IPSEC SA. We don't see any SA in here. Oh, this is IPv6. I need to put to show crypto IPSEC SA. Oh, and that's no, but it's not showing for either IPv4 or IPv6. Config T interface gigabit 0/1. Shut it down again. Show crypto map. Right, show crypto map. So the peer 20.1.2. That's good. We have a bunch of permits over here. Extended access list. Current peer. So it looks like we have a peer. So what if we do let's do a config T. Let me do ping 20.1.1, 20.1.1.2. Show crypto IPSEC SA. Nothing encrypted. So nothing is getting encrypted right now. Still using port 500. But I bet you if I remove the NAT, so you can see protected. Yeah, we don't have VRF, blah blah blah. 192, 172. So you can see that we have a couple over here. Let me see. Was I not looking? I was looking at the correct one. So this is the peer. The first one, second one, third one. So we have a couple over here. So this is 20. This for 172. No, nothing encapsulated, nothing. So we have one, which is protected VRF, none. 192. The local and the remote. Do we need to do okay? So if I'm going from over here, but the thing is that whenever I ping from this local guy, it's going to be netted, and it's going to be basically 20.1.1. So what if we just do a config t IP access list extended VPN. So IP permit, let's permit an IP 20.1.1.1. Oh, it is to be subnet. So that's not going to work, because if I want to permit this guy to this one, I'm just basically permitting. But what if I just permit like a single one? 220, just to make it go. Yes, now I think I need to allow that to permit. So if we do, let's permit IP, let's go and negate this. Let's go ahead and exit do show IP NAT, or do show run. I'm going to remove pat, include NAT. So let's go ahead and do no IP NAT inside source list 1 interface gigabit 0/ overload. So now if I ping from router 6 20.1.1.2, what is going to happen? I'm unable to ping 20.1.1.2 now. Let's go ahead and show IP route. So from router 13, okay, what if over here, show IP route. We do have that network. Router 12 has the show IP route. It does have that network via BGP. Debug IP ICMP. Let's see what happens whenever I ping from router 6. Okay, so something we're getting hits. Show IP access list. 26 matches, so 10 permit to this network. It should allow, okay, permitting the through network, one match. Let's go ahead and try it again. We have 30 matches, so it is getting over here. 172.16, that's 0.0, 0.0, that's 255, that 255, that 255, 220, that 1.0. So it is going over here to the 20 network, but it's not getting to this at all. So let's go ahead and show crypto IPSEC SA. This is the local and remote. Let's go ahead and go to show crypto IPSEC SA. Let's look for the local 172 and remote 20.1.1.1. So it's this one. And it's not matching. We don't see anything. It's getting encrypted or decrypted. So once again, I'm gonna have to do more research. I believe I got this working. I mean, we can see the IPSEC are being formed. The IPSEC Security Association. Or for some reason, not working. I don't know. Let me go ahead and take show run, and also do a show run over here. So crypto policy. Okay. Okay, I think I found it. I think I know what it is. So let me see. So we're doing transport. That's fine. Whatever. Let's go ahead and change that to config T. Since we removed the NAT, let's go ahead and change this back to mode tunnel. Do the same over here. Crypto IPSEC transform set. Config T. I always forget to do that. Config T. Mode tunnel. Still not able to do it. Interface gigabit 0/1. Shut down. Interface gigabit 0/1. Shut down. No shutdown. No shutdown. Still not able to ping 20.1.1.2 from router 6. And if we can see, and let's show IP access list, we can see that it keeps getting, we keep getting a hit right here. Are we getting hits over here? Show IP access list. So we have this 20.1.1.1. So we're saying hop on the tunnel. So it is getting to the tunnel. Let's do a trace routes 20.1.1.2. Harsh, you are on the right track. So check the IP address of the destination and source for IPSEC. I think I did that, but give me 1 second. So we are getting to, the ICMP time exceeded, time to leave, sent to destination, base. So it is only getting to my default gateway. Then after that it dies. Send the ICMP time exceeded, time to leave, send to destination. And this guy over here, router 12 is not doing anything. What if now we ping 20.1.1.2? So we're able to ping 20.1.1.2, blah blah blah. Show crypto IPSEC SA. Okay, I might have to implement. VTI. I think it's called VTI or DVTI. Now SVTI, so static virtual tunnel interface. I'm gonna have to implement, so I can also use NAT config T. Let's go ahead and just insert right here IP NAT, and we're going to do an IP NAT inside source list gigabit 0/1. Let's go ahead and put that source list 1 0/1 over low. As in this IP inside source list 1 interface gigabit 0/1 over low. So we're going to do this, and in the next video we are just going to implement. I thought with site to site was going to work, but I did before. I did it with. I have not done it with. Let me go ahead and save my configuration over here. Do WR. Let's just save it over here. Let's also save it over here. Okay, so yeah, I'm just going to configure as VTI, so a static virtual tunnel. I know with that it's going to work. I just thought for some reason IPSEC tunnel and doing those access list was going to work, but it didn't work. That's fine. That's more videos that I need that I'm going to be doing. And also after I configure that IPSEC or that static virtual tunnel, I'm going to be configuring static NAC over here. We are going to be configuring IP addresses for this, for all these 3 servers. Two servers are going to be web pages, and another one is going to be FTP. So we are going to be saving FTP. It's saving basically our configuration from all of these routers and switches, so we can save all the configuration on that FTP server, and then we are going to configure 2 websites basically, so we can access those websites, and then at the end, probably we should be ending this by Wednesday. Hopefully, we are going to be configuring AAA. AAA is kind of cool to configure. So thank you guys for watching. I am really tired. It is Sunday. I was working all day outside. So yeah, thank you guys for watching, and I will see you in the next one, guys. Bye bye.